All right, we continue with our series of logarithmic equation. We've discussed some multiplication law, subtraction law. Now we're moving to power law. All right, power law states that if log to base a of x of y, what you should have is y log to base a of x. All right. E.g., if you have logarithm to base 2 of 2 of 3 or logarithm to base 3 of 3 of 4, what this simply means is that logarithm to base a of raised to the power of x raised to the power of y simply means that y, all right, is the multiplier of logarithm to base a of x, as we are having in this case. But if you want to solve this, all right, what you should look at critically is this. We are having logarithm to base 2 of 2 of 3. All right, let's look at logarithm to base 2 of 2. We all know that logarithm to base 2 of 2 is 1, because any logarithm to its own base always is equal to 1. Any logarithm, whether if it is 1,000 raised to the power of 1,000, the logarithm of 1,000 raised to the power of 1,000 is 1. The logarithm of 10 raised to the power of 10 is 1. The logarithm of 5 raised to the power of 5 is 1. The logarithm of 20 raised to the power of 20 is 1. The logarithm of 30 raised to the power of 30 is 1. So it's a law. All right, the logarithm of any number to its own base is always 1. So please take note of that. Now, if we can establish this will now become 3 log to base 2 of 2. All right, but log to base 2 of 2 is equal to 1. So that means you're going to have 3 times 1, which is equal to 3. All right, which is equal to 3. All right. Also for the second one, the same thing. All right. For the second one, you have logarithm to base 3 of 3 of 4 is the same as 4 logarithm of 3 to 3. Remember, logarithm of any base to its own power is 1. So here you're going to have 4 by 1, which will still give you 4. Okay? So, how about if we look at another example? Alright, how about if we look at another example? You are asked to simplify log 81 all over log 1 over 27. Good. Let's look at something like this and see what we're going to have at the end of the day. Alright, so we are given log 81 over log 1 all over 27. We can change this to be log, because we can find the common factors of all these numbers. One of the most significant amongst them is 3. As an indices student, you should know that 3 can play a role in 81 and also in 27. So we can change it to be 3 raised to the power of 4 can give me 81 over log of 3 raised to the power of 3. 3 raised to the power of 3 can give me 27, but I want to change this. When you have log to base, logarithm of 1 over 27 is the same as log of 27 raised to the power of minus 1 is the same. Alright? So imagine if I change this to log 81 over log 27 raised to the power of minus 1. Yes. Let's leave it this way, so that it now becomes log of 3 raised to the power of 4 all over log of 3 raised to the power of 3 of minus 1. Okay? So invariably, when you look at this, you're going to have log. Okay, let me come up here so that you get what I'm doing. Alright? So we're going to have log base 3 of 4 all over log to base 3 of, when you multiply this, 3 times minus 1 will give you minus 3. This will now become minus 3, alright? So this can take care of this. You have 4 over 3 minus 3, as your final answer. So I believe with this, you've seen the effect of power law itself to numbers, alright, or any given logarithm. In our next class, we're going to look at combined operations all right, that involve multiplication, addition, division, all combined together, including power and how can we relate with them. The pedagogy involved in handling this kind of problems will also be explained properly to all viewers and to all students. So like I said earlier, please follow my page, like, share and comment. Subscribe to my YouTube page. Thank you. See you in my next video. Bye.